Hi, my name is Jorge, and this is my Portafolio Optimizer application for Project 2. This is a web app built with Streamlit that takes a set of stock tickers, pulls real historical price data, and uses mathematical optimization to find the best way to allocate money across those stocks. Before I dive in, I wanted to be upfront. I used AI, specifically Claude, to help me build this application. Claude helped me write the code, debug errors, and structure the optimization logic. I've included a full AI disclosure in my submission. I also submitted driver documentation, which summarizes what was built, what design decisions were made, and exactly what AI was used for throughout this project. Both of these are part in my submission package. Now let me show you what the app does. Um, in the sidebar, I have all of my controls. I started by entering stock tickers anywhere from 5 to 15, comma separated. Right now, I have 10 stocks already loaded, which are Apple, Microsoft, Google, Amazon, JP Morgan, Johnson& Johnson, Visa, Procter& Gamble, and Nvidia and Exxon. These are all real tickers pulling live data from Yahoo Finance. So you can see they're all here, and let me show you it actually works. Let me change it to just 5, for example. Here it is, and as you can see, everything changed. But for this project, I'm gonna go back to my original 10. Perfect. Here you can see all of them. So, below the tickers, I also have a date range selector defaulting to 3 years of historical data. Now, here on the optimization settings, this is the most important part. I have 3 options: the maximum Sharpe ratio, the minimum variance, and target return. Right now, it's on the maximum Sharpe ratio. The Sharpe ratio is the portfolio's return above the risk-free rate dividend by its volatility. Maximizing uh, Maximizing, it means finding the portfolio that gives the most return per unit of risk. I chose this as the default because most investors aren't just chasing high returns. They want high returns relative to the risk they're taking on. It's the most practical, widely used objective in portfolio management. Um, Now here you can see these 3 numbers at the top will show you the result, which are the expected annual return, the expected annual volatility, and the Sharpe ratio. Here, if I go on to minimum variance, this objective is completely ignores return and only minimizes volatility. So as you can see, the volatility number drops, but so does the return. This is the right choice for a very risk-averse investor who prioritizes not losing money over growing it. So you can see the change from those two. Now, I have target return. I tell it that I want a 20%, for example, uh, yeah, 20% annual return, and it finds the least risky allocation that hits exactly that target. This shows you how you'd work with a client who has specific required return they want, so you can switch it over. You can see that the numbers changed. I'm gonna switch back to the maximum Sharpe ratio. Um, So quickly on how expected returns are estimated, the app takes daily closing prices, calculates daily percentage returns, averages them, and multiplied by 252 trading days to analyze. The covariance matrix is analyzed in the same way. The key limitation is that historical returns don't guarantee future performance. NVIDIA returning 80% last year doesn't mean it'll do it again. More sophisticated models like CAPM or Black Litterman incorporate forward-looking estimates, but they add complexity. For this tool, historical averages keep things transparent and reproducible. Um, as you can see here are the constraints. Let me show you how they work. The max weight per stock is currently 40%, meaning no single stock can take more than 40% of the portfolio. As you can see on the weight allocation, the max is 40%. You can see the optimizer is concentrating heavily in a few stocks, the one with the best risk-adjusted returns. Now I'll drop the cap to 15%, and watch the weights. Everything's spread out. No stock dominates anymore, but if I scroll up, the Sharpe ratio, sorry, here, the Sharpe ratio dropped. Now, if I go back here, when I restrict what the optimizer can do, it can't concentrate in its best ideas, so performance also falls. This is the trade-off. The tighter constraints mean more diversification but lower risk-adjusted returns. Real fund managers deal with this constantly. Regulatory limits, index tracking requirements, client mandates all impose constraints like this. So I'll slide that back to 40. And I'll slide this to 5. Um, it can also enforce a minimum. So at a 5% minimum, every stock gets at least some allocation, which is useful if you want guaranteed exposure to every name in the portfolio. I'm gonna slide it back. Well, as you can see there, I'm gonna slide it back to 0. And the risk rate, I'm gonna move it to 8. The risk rate, as you can see, it's also adjustable too. Moving it from 5 to 8 basically raises the benchmark, so it is harder to beat. So the Sharpe ratio shifts. Think of this as reflecting changes in a treasury bill rates. I'm gonna return that to 5. Here. This is the efficient frontier. Each dot is one of 3,000 randomly generated portfolios, random allocations across the 10 stocks, plotted by the risk on the x-axis and return on the y-axis. The color goes from purple for low Sharpe to yellow for high Sharpe. The left edge of this cloud is the efficient frontier. Every portfolio sitting on that edge is optimal. You can't get more return for the same risk, and you can't reduce risk without giving up return. Portfolios inside the cloud are suboptimal. Now, the red star is the maximum Sharpe portfolio, the tangency point where the line from the risk-free rate just touches the frontier. Then here the green diamond is the minimum variance, the absolute lowest risk portfolio possible with these stocks. Then the X is my currently selected portfolio with Max Sharpe active. It sits right on the red star where an investor chooses to sit on this curve is purely a functional of their risk tolerance. Conservative investors sit left, aggressive investors would sit right. Now, the correlation heat map shows how stock moves relative to each other. Red means that they move together, blue means that they move opposite. The optimizer uses the thorough this through a convergence matrix. So stocks with low correlation to each other reduce overall portfolio volatility, which is why this diversification works. Um, this comparison table puts all three strategies side by side, return, volatility, and Sharpe ratio. You can see the trade-offs immediately. Um, and this is a grouped bar chart, shows the weights actually differ across strategies. So Max Sharpe concentrates, mean variance diversifies. If I were on the target return, you'd see a third set of bars fall somewhere in between. This chart makes the effect of each objective completely visual. To wrap up, this app accepts 5 to 15 tickers, pulls historical price data from Yahoo Finance, runs mean variable optimization with 3 objective choices, lets you adjust constraints and the risk-free rate, and visualizes everything through an interactive efficient frontier, correlation heat map, and comparison charts. The driver documentation and AI disclosure are included in my submission. Thank you.